Alright, welcome back, and let's just continue on with the related rates topic with yet another example. So this example will have to do with two objects moving towards each other on an intersection. And let's just start here. So there's object A, which approaches the intersection at 2 meters per second. Approaches the intersection as 2 meters per second. And there's object B, which is moving away from the intersection at 1 meter per second. And we have to find out, and the current positions of these two objects are that A is 10 meters away and B is 20 meters away. So A is 10 meters and B is 20 meters. So, and just find out the change of theta again. So we have to find d theta over dt, and just find how this changes with respect to A and B moving towards and away from the intersection. So let's just draw a quick diagram of what this all actually means. So here are the two things. So let's call this line here, this segment here A, and this B. And A is, this from here to here is 10 meters long. Just get rid of this. And B from here to here is 20 meters long. And we know that the dA over dt, which is A is approaching the section, so it's negative 2 meters per second, because when you're going this way, it's negative, and you're moving away, it's positive. And this right here is the intersection, as you can see. And this is moving away at, so dB over dt is positive 1 meters per second. So that's pretty much the whole sketch. And so what we would have to do now is, again, find a relationship between A, B, and this is the theta that we are measuring against. So A, B, and theta. And because we want to find, again, the change of the angle with respect to time as these two objects move towards and away from each other. So let's begin finding the actual relationship. The easiest way to do this in this problem is, again, to use tangent. So the tangent of theta is opposite over adjacent, so it's equal to A over B. So A is equal to B tangent theta. And since we already know the corresponding rates, we already know the changes with respect to time, we can just take the derivative right here without having to find an actual relationship between A and B. So we don't have to, in this case, combine any variables together. So if we do differentiate this, we can get dA over dt is equal to, so using your known rules for differentiation, you can get b secant squared theta d theta over dt plus tangent theta dB over dt. So once we get that, we can, so now we should also find out, we should see if we have all these variables. So we know dA over dt, we know dB over dt, we have B and we have A, and we want to find out d theta over dt. But first, let's figure out the current value of this theta. So tangent, well, theta is equal to 10 over 20. And so this theta is going to be, so this is equal to 1/2. So tangent theta is equal to 1/2. And so if you take the theta inverse and you put it into your calculator, you can get you get 0.4636. This is one way of doing it, and you can plug this into here to find theta. But an easier way of doing this to find secant is to just know that 20 squared plus 10 squared is 500. The square root of 500 is the hypotenuse of this. And if you want to find cosine, because secant is 1 over cosine, if you want to find cosine, it's just opposite over adjacent over the hypotenuse. So it's just going to be square root of, it's going to be 20 over square root of 500. So secant will, theta will equal square root of 500 over 20, and squaring this will just give you 5 over 4, because it will be 500 over 400, which is 5 over 4, which is 1.25. So we've now found out the secant squared theta for this problem, 1.25. So let's go ahead back here and plug all our numbers back in, because now it's just a matter of plugging these back. So d over dt is -2. The b is 20, because that's the distance away. Secant squared is 1.25. d theta over dt is our unknown, plus tangent theta we already know is 1/2, because this is tangent is 10 over 20, so it's just 1/2. I'll just write 0.5, and dB over dt is 1, so times 1. So if we simplify this, you get -2 is equal to 25 d theta over dt plus 0.5. You take this to the other side, you get -2.5 is equal to 25 d theta over dt, and in d theta over dt is equal to -0.1 radians per second. So this is the rate of change of the angle.